Okay guys, hello again. I want to continue what we have started in the last video. Now we can say the opposite as well. If I have two parallel vectors like this, in this case they must be scalar multiple. There must be a factor I multiply this vector by to get this vector. Alright? So parallel vectors are scalar multiple of each other. Parallel vectors are scalar multiples. Also, because we know that we can move, if I move this vector here, this will be the same. So we also can call them collinear. Collinear because they share the same line, even if it is in the opposite direction, like this is 100 and this is 300. They are scalar multiple, so I can say in here, if this is A, this will be negative 3A. They are also parallel but opposite direction, and we can say that those are collinear because I can put this in, I can move this from here to here, and this will be in the same line. Okay, so if I want to prove that these vectors are parallel or collinear, I just need to prove that they are scalar multiples. We're going to learn that more when we do algebra with the vectors. But I just wanted you to understand this concept that parallel vectors has to be scalar multiple of each other. Okay, so let's say I want to, if I have vector u like this is 5 Newton, this is vector u, and I have vector v is 15 Newton. I cannot say that vector u equal 3 I cannot say that vector v equal 3 vector u. This is not right because they are not parallel. They just, the magnitude, what I supposed to write is the magnitude of vector v equal triple the magnitude of vector u. In this case, this is right. So in order to have, if I say vector v equal 3u, they must be parallel. They must be parallel or collinear. Okay, so in here this is not the case, so I can only say that the magnitude of vector v is triple the magnitude of vector u. Okay, now I want to introduce you to a new very important thing. It is called unit vector u. Unit vector u. We write it like this and we put a little tilde to say that it's a unit vector. What is it? It is a vector in the same direction as vector u, a big vector u, with a magnitude of 1 unit. So let's say this is vector u. What is vector unit vector u? It is this vector, it is in the same direction as u with a magnitude equal 1. So the magnitude of vector u is always 1 unit. And I can also draw it here. It is in the same direction, but its magnitude is 1. Okay? The length of the unit vector is always 1. It is, so if I say unit vector c, this is vector c. Sorry, vector c. What is the unit vector c? It is a vector with a magnitude in the same direction of c and with the magnitude of 1. Okay? Alright, now I want to explain something to you. Unit vector u equal vector u divided by the magnitude of vector u. Let me explain what does that mean. Let's say we have a vector that is 10 units. 10 units. Okay, this is vector u. Okay? This vector u is in the same direction and as u, as vector u. Unit vector u is in the same direction as u. So they are scalar multiple of each other. What is the value I multiply vector u by to get unit vector u? Remember, this is 10, this is 1. This is always 1. Right? So what number I multiply vector u? I multiply vector u by to get the unit vector u. I will multiply it by 1 over 10, because if I multiply 1 over 10 by 10, I will get 1, which is the magnitude of vector u. So this means I can say I will divide it by 10, which is the magnitude of vector u. So I can say that unit vector u equals vector u divided by the magnitude of vector u. Okay, I want to re-explain this. Any vector divided by its magnitude, its length, will give us a vector in the same direction as the vector with a magnitude of 1 unit. And this is what we call it the unit vector. Okay? So let's say I have v equal, the magnitude of v equal 100. That means unit vector v will equal vector v divided by 100, which is the magnitude of vector v. Just dividing by the length will give us 1 unit in the same direction. Okay? Alright, so I want to give you an example. And this is an important example. Unit vector x and unit vector y has an angle of 30 degrees between them. I told you before, when we are talking about the angle between vectors, we are talking about the angle between the tails. Yes. Okay. Alright, so this is the question. It says we have two unit vectors u and y. All I know that both of them are unit vectors, so the magnitude of vector, this is, let's say, x, and the magnitude of vector y, unit vector y, is, both of them are 1, and the angle between them is the angle between the tails, it is 30 degrees. Okay, we need to calculate the resultant of 2x. So I will draw the first vector, 2x. What is the length of that? This will be 2 units. And minus y. So from the head, y goes this way, minus y will be in this direction. Okay? And the angle, if you look, this was y. This was y, and the angle here was 30. If I double this, it will stay 30. So from this is the Z shape, this is two parallel lines, and the angle, so the angle between them will be the same. So this is 30 degrees as well. Okay? Now, what is the resultant of this? It is the vector that closes the shape, connect the tail of the first with the head of the second. So this is the resultant vector that we need to find. Okay? In order to do that, I have the length of this is 2, the length of this is 1, and the angle between the two, the angle here is 30 degrees. I want to find the resultant. So, as we learned in grade 10, this is not a right triangle, so I cannot use SOHCAHTOA. I have to use either sine law or cosine law. This is two sides and angle included, so I have to use cosine law, which says this is squared, square root of 2 squared plus the second vector squared, 1 minus 2 times 2 times 1 cosine the angle between them. This is the thing. If you do this calculation, you're gonna use the order of operation. So you square and you multiply and you add and subtract at the end and find the square root at the last step. And if you do that, you will get 1.24. Now I know that the length of this is 1.24. I need to find this angle because it's a vector, and in order to find the vector, it has to have a magnitude which is 1.24 unit, and this angle. So let's say this is angle theta. I have three sides on this, so I can say that sine theta over 1 equal sine 30 over 1.24 sine log, and if you apply this, you will get the angle. So sine theta will equal 0.5 divided by 1.24. So theta equals sine minus 1, 0.5 over 1.24. I hope I have time. So inverse sine, again we have to be on in degree mode. So the measurement of this angle is almost, it's 23.78. So when we write this, we have to say, to describe this angle, so we say this is R has a magnitude of 1.24 and makes 23.78 degree angle with vector x of vector u, vector y, because you see it's away from 1. Okay, so I am done. I will post this and I will post the homework, and I'm waiting for your questions. Have a great day. Bye.